In this video, let us discuss about the construction and working of a carbon dioxide laser with its energy level diagram. Carbon dioxide laser. It is a molecular gas laser, and the pumping scheme here is 4-level pumping scheme. The next, the active ingredient here is the mixture of carbon dioxide, nitrogen, and helium. The main ingredient is carbon dioxide. To excite the carbon dioxide, we have nitrogen, and to cool the heat generated during this process, we have helium here. Sometimes hydrogen and vapors of water are also used in place of nitrogen and helium. And the process of pumping involved here to excite the uh, nitrogen to the excited state is electrical discharge. Then optical resonator, we have two concave mirror kept or kept at the both ends of the discharge tube, which forms as the optical resonant cavity. And output wavelength from this laser is 10.6 micrometer and 9.6 micrometer in the infrared region, which we cannot see through our eyes. And among these two wavelengths, 10.6 micrometer is more intense than the other wavelength 9.6 micrometer. Generally, all other lasers gives us pulsed outputs, but here the nature of the output in case of carbon dioxide laser is both continuous. If we want, we can use it in the pulsed mode also. And we have a very high power output of 10 kilowatt from the laser. The laser action here takes place between the vibrational energy states of carbon dioxide. So the principle of carbon dioxide laser is the transition will takes place between the vibration energy states of carbon dioxide molecules. Now let us discuss about the energy states of carbon dioxide molecules. We know the carbon dioxide have one carbon atom and two oxygen atom. So the carbon atom will be sitting at the center, and the two oxygen atom will be at the two extreme ends of the carbon. So the carbon dioxide, these three molecules will vibrate in three different modes. The first mode is called symmetric stretching, then bending, and third one is the asymmetric stretching mode. First one is the symmetric stretching mode, where the carbon will be sitting at rest at the center, and the both oxygen will be vibrate. Either they will move towards the carbon or the move away from the carbon along the axis of the molecule in a linear fashion. This is the symmetric stretching mode. Next we have bending mode, where the carbon will be at the center, but the oxygen sitting at the extreme ends of the carbon will vibrate perpendicular to the axis of the molecule. So you can see the the mode of vibration in the picture. Then we have asymmetric stretching. In this, both oxygen and the carbon atom vibrate asymmetrically. The carbon will move in one direction, and the oxygen sitting at the corners will be vibrating in the other direction. There will be no symmetric stretching here, so we call it as an asymmetric stretching mode. Next, coming to the construction of the laser, it has a discharge tube made of quartz. Then to evacuate the tube, we have a vacuum pumper here, like a diffusion pump. Then we have a entry for sending the active medium, that is for sending carbon dioxide, nitrogen and helium here. And then here in the figure you can see M1 and M2, which forms the optical resonant cavity. Here M1 is a fully reflecting mirror which uh, reflects back the electrons back into the discharge tube. On the other end, we have partially reflecting mirror through which the laser light comes out. Then we have for pumping process, we have a power supply here which excites the nitrogen atom inside the discharge tube. So as I said, it has a discharge tube made of quartz which is around 5 meter long and 2.5 centimeter in diameter. So we fill the discharge tube with a gaseous mixture of carbon dioxide, helium and nitrogen. In the picture itself, you could have seen on both the ends of the discharge tube, they are inclined at a certain angle. This is for polarizing the laser light coming out. This arrangement we call it as an Brewster's window. Then we have two concave mirrors. One is completely reflecting, another one is partially reflecting to form an optical resonating cavity. Now let us discuss about the working. To understand the working part, we need to understand the energy level diagram. See, on the left hand side, we have a energy level diagram for the nitrogen. So initially, the mixture of gases will be at the ground level only. When electrical discharge is given to the quartz tube, the nitrogen sitting at the ground state will gain some energy from the free electrons, and then they will move to the excited state of the nitrogen. The excited state of the nitrogen and the E5 level of carbon dioxide are of same energy. These excited nitrogen will collide with the carbon dioxide molecule and it transfers its energy through collision to the carbon dioxide. So the carbon dioxide atom will automatically move to the E5 level, which is in resonance with the excited state of the nitrogen atom. Now the electrons or the carbon dioxide molecule sitting at the excited state, if any chance photon hits it, they will transit to either to E4 level or either to E3 level. If they move to E4 level, the output coming out of this is 10.6 micrometer. If they make a transition to E3 level, the laser output will be 9.6 micrometer. Both these wavelengths are in the infrared region. So when an electrical discharge occurs in gas mixture, as I said, the electrons collide with nitrogen molecule and they are lifted to the excited energy state. So equation wise we can write the nitrogen when acquires electron from the electrical discharge, it goes to the higher energy state N2 star. So this excited energy level of nitrogen is almost close to the E5 energy level of carbon dioxide. So these carbon dioxide molecule acquire its energy by energy transfer, and we have population inversion created there. That means more number of carbon dioxide molecules are in higher excited state compared to the lower excited, ground state. So these carbon dioxide molecule will shift to the ground state with emitting the excess energy or by transiting to the lower energy level. So there are two possible laser transition as we have seen it in the energy level diagram itself. One is transition from E5 to E4 level, which produces a laser beam of wavelength 10.6 micrometer, and E5 to E3 gives us a laser beam wavelength of 9.6 micrometer. So generally we can expect 10.6 micrometer transition, which is more favorable than this 9.6 micrometer transition. So we get a high output power of 10 kilowatt from the carbon dioxide laser. So here during this laser action, more amount of heat energy is generated. To cool the discharge tube, we have hydrogen gas. The main advantages of using carbon dioxide laser is the construction of the laser is very simple, and we get a huge output from the laser, and it is continuous also. Whereas other solid state lasers give pulsed outputs. Here carbon dioxide laser gives us the continuous wave output. We can also make carbon dioxide laser to work in pulsed mode also. It has a high efficiency, high output power. If you want to increase the output power, we can simply increase the length of the discharge tube. Though it has lot of advantages, it has disadvantages also. The heat generated during the though we have a helium there, the heat generated during the uh, laser action reduces the efficiency of the laser. Uh, at the corners or the ends of the discharge tube, there may be a corrosion taking place. Since the light coming from the or the output coming from the laser are in infrared region, these infrared regions are invisible to our eyes. If in case accidentally we um, see or encounter this laser light, we may damage our eyes. Carbon dioxide finds lot of applications in industry level. It is used in material processing, in welding, drilling, cutting, and soldering. In communication purpose, it is used in open air communication. It is used in remote sensing. In especially carbon dioxide laser is used in skin treatment to remove tattoos, warts, moles, and the skin related ailments. It can also be used in liver and lung diseases treatment.